The other example we're going to look at is this one here. We have second degree polynomial on the denominator, first degree polynomial on the numerator, so we're all good there. The denominator hasn't been factorized yet, so we have to do that. Now I look here and I see that the coefficient of the x squared term is not 1, it's 3. So this is a more interesting factorizing problem. There's a YouTube channel called Math BFF where they look at a technique for factoring called the Magic X technique. So I'm going to go ahead and link that, or you can look it up. And this is a technique I'm going to go ahead and use now. So what we do is we draw a big X, not that big, and we say the first coefficient times the last number, it's 3 times -4, that makes -12, and the middle number is -11. So I want two numbers that multiply together to give -12, but they add together to give -11. And I think, then I say, aha, how about 1 times -12? Well, that works, that's fine. Now what I do is I divide those two numbers by the quadratic coefficient, and then I simplify them. So 1/3 is already in its simplest form, and -12/3 becomes -4/1 in simplest form. And now for each of these fractions, they describe a factor. And the denominator of the fraction is the coefficient of the x term. So this x term will have a coefficient of 1. And the numerator is the constant term that we add on. So there we've factorized it. Excellent. So we're going to go ahead and use that. So I write my numerator over my factored denominator, and I express that as a linear combination of, well, reciprocals. Anyway, I write it in the normal partial fractions way. There we are. And now, just as before, I multiply everything by both factors. Over here, both factors cancel out, so I have 4x take 2. Over here, the factor which doesn't cancel out is x minus 4, so I have c1 times x minus 4. Over here, the factor which doesn't cancel out is 3x plus 1. There we have it. And then I go and expand all the brackets. and I've rearranged it. So I take the two x terms here, two constant terms here, and then I can take out the factor of x. There we have it. And just like before, we have the x stuff and the constant stuff. So x stuff and the constant stuff. I write that as two equations. There we have it. And we can divide everything by x. Bang, bang. We have two equations with two unknowns. Not bad. I'm going to rearrange. I see that I have just C1 by itself here. So I'm going to say rearrange, make C1 the subject in this first equation, then substitute that in here, and it will reduce the number of unknowns. So I'm going to subtract 3C2 from both sides. So everywhere I see C1, I can swap it out for 4 minus 3C2. And I see this over here, so I substitute it in. I have negative 4 times C1, so it's negative 4 times 4 minus 3C2. There we are. Okay, well, brackets. Let's get rid of those brackets. Let's expand the brackets. So negative 4 times 4 makes negative 16. Negative 4 times negative 3 makes positive 12. Okay. Now I'm going to add 16 to both sides. So negative 2 plus 16 makes 14. Adding 16 over here just gets rid of that negative 16. And these two are like terms, so they come together. 12C2 plus C2 makes 13C2. And this is going to be messy, but I can divide both sides by 13. So C2 is 14 over 13, which can't be simplified any further. And now we're going to put that in here to find C1. So all right, so 4 minus 3 times 14 over 13, the value of C2 equals C1. What I do is I take 14 times 3, which makes 42. And I change 4. If 1 can be expressed as 13 over 13, then 4 can be expressed as 4 times 13. 4 times 13 over 13. 4 times 13 is 52. So 52 minus 42 is 10. So C1 is 10 over 13. And that's a bit messy, but it's okay. Now our integral becomes integral of 10 over 13 over 3x plus 1 plus 14 over 13 times x take 4 with respect to x, and then just like before, this is 10 over 13 times 1 over that, so we have 10 over 13 times ln 3x plus 1, and then we have to divide by the derivative of the inside of that bracket, which is 3. It's not 1 in this case. Then we have 14 over 13 times ln of x take 4, divide by the derivative of the inside of the bracket, which is 1, so that's fine. And always, always, always add a constant. So we can express this in the end as, if we have 10 over 13 dividing by 3, that's like 10 over 13 times 1 over 3. This denominator gets tripled. Bam, 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 bam. And there's our answer. Whew. Well, that's intense. Well, it's not really intense. It's just a lot of work. So let's rub that all out.